In this episode, you'll learn the most important facts about a tank's primary armament, which cannon was used on the first tank, why howitzers were installed on some tanks, and how a tank cannon differs from a field cannon. Almost all tanks have a cannon, the essential instrument with which they will complete combat missions. Cannons were used even on the first tanks. As tanks continued to develop, the cannon remained virtually mandatory for all tanks except command vehicles and certain special-purpose tanks. The first tank guns were adaptations of existing artillery pieces or naval guns. The first British mass-produced tank, the Mark I, had 57mm naval guns. The French Renault FT-17 had a cannon based on an infantry gun. The basis for the German Tiger's cannon was an 88mm anti-aircraft gun. Starting in the 1930s, some guns were designed specifically for use on tanks, but this approach was still not universal when World War II started. Howitzers were sometimes mounted on tanks. Howitzers are guns with relatively low velocity, designed to fire mainly at enemy fortifications and troops. A howitzer can engage using either a flat trajectory or with the high, arcing trajectory of an artillery piece. To be effective against enemy tanks, a howitzer would have to be of a very high caliber, which would typically entail a low rate of fire and severe recoil forces. The famous Soviet KV-2, with its 152mm howitzer, could only shoot while standing still, and the turret had to be at a certain angle to the hull. Firing the gun outside this range of orientation was guaranteed to jam the turret. A long-barreled, high-velocity cannon is more suitable for accurate direct fire. This is important when shooting moving targets, including armored ones, and for this reason, almost all tanks have this type of armament. Let's examine how the tank cannon is structured. It is usually mounted in a turret. In the front of the turret, where the gun barrel exits the turret, is an armored shield, the mantlet. Near the mantlet, the gun barrel is protected by an armored housing that reduces the chance that the barrel will be damaged by shrapnel or spall if the mantlet is hit. The cannon is installed into a mounting known as the cradle and held in place by a pair of horizontal protrusions called trunnions. Rotation on these trunnions allows the gun to aim in the vertical axis. Traversing is done by turning the turret. The breech assembly includes the breech itself, consisting of a lock, firing pin, and extractor. The equipment can be semi-automatic or automatic. The lock is needed to seal off the barrel during the shot and prevent the blast of propellant gas leaking into the combat compartment. During World War II, most tanks in the world had wedge breech blocks, which were simple, reliable, and provided a reasonably fast and reliable lock. Semi-automatic and automatic breech equipment was developed to reduce the time needed to open and close the breech and improve tanks' rate of fire. Nowadays, many tanks have mechanisms to assist loading. With their help, the firing rate can reach 10 shots per minute, at least in theory. In practice, under combat conditions, the rate of fire is likely to be much lower. For the firing pin to strike the shell's primer, it needs to be activated with the trigger. A precise shot calls for minimal delay between the pulling of the trigger and the shot itself. Gradually, mechanical triggers on tanks were replaced with electromagnetic ones. These reduce the delay significantly. Finally, the extractor removes the blank cartridge from the barrel after the shot. When firing any firearm, there is recoil. A tank cannon is no exception. The gun mounting endures a force that can reach hundreds of tons. That is why the barrel slides back. The longer the recoil distance, the less force is transferred to the tank's turret. However, there isn't much room inside the turret, so a long recoil distance is not an option. On the other hand, because of the tank's weight, the gun is more stable than the equivalent field gun mounted on a light, Y-shaped frame pressed against the ground. That's why tanks can tolerate a relatively powerful recoil. The recoil absorber is a hydraulic buffer. The recuperator is the second element of the recoil absorber. Its purpose is to return the barrel to the firing position. An additional element that helps reduce the recoil of powerful guns is the muzzle brake. Propellant gases exiting the barrel are redirected by the muzzle brake and counteract some of the recoil force. This reduces the recoil distance necessary. However, there are drawbacks to these devices. The muzzle brake creates both a large flash and a cloud of smoke that is likely to reveal the tank's firing position. They can also mask the target, so the gunner may have trouble adjusting his aim. The barrel is a tube made of high-strength steel. The barrel walls have to be strong enough to withstand the enormous pressure exerted at the moment the shot is fired. The higher the gun's caliber, the stronger and thicker the walls of the barrel must be. The rifling grooves of these high-velocity guns wear out pretty fast. To increase their durability, the designers started using two tubes, one inside the other. Designers also searched for new and improved steel alloys. Stronger types of steel allowed the barrels to be thinner and lighter. The inner part of the barrel is called the bore. The bore has spiraling grooves, the rifling. These grooves cut into the driving band of the shell as it passes through them, giving the shell its spin. Rifled guns were used on tanks up to the 1960s, after which smoothbore guns began to appear. Smoothbore guns could be mounted in larger calibers and had a higher initial shell speed. They were also simpler to manufacture and maintain, and in addition to firing ballistic shells, smoothbore cannons can be used to launch guided anti-tank missiles. When a gun is fired, the propellant gases are directed out through the barrel. But when the breech is opened, fumes are sucked into the combat compartment. This is dangerous for the crew. The fumes are poisonous. In the comments, you asked how the crew is protected from these fumes. When the gun caliber wasn't too big, a fan could clear the fumes from the combat compartment. Later, this problem required a different approach. One solution was the bore evacuator. It is a cylindrical cell on the barrel, connected to the bore with nozzles. During a shot, the evacuator is filled with pressurized gas through the nozzles, and after the shell exits the bore and the pressure drops, the evacuator is emptied. The flow pulls the gases from the gun's breech and prevents the crew from inhaling the poisonous fumes. Another solution that can be used, either together with the evacuator or separately, is the installation of a compressor. After the shot, the compressor blows a stream of air through the bore, pushing out the combustion fumes and removing the gas cloud which might obstruct the gunner's vision. In some cases, compressed air also forces the fumes from the case trap. The gun could be considered the most important part of a tank, but without a crew, it's useless. This makes them the most important part of a tank. That's why, even today, tank designers are working on more and more effective ways of protecting the most important component of the combat vehicle, the people inside.